Hi everyone, I'm Barış, and together with my teammates again Zeynep, we developed a monkey bot called ARChie. The primary objective of our project was to create a robot capable of moving between two poles along a rope, adapting to different levels of tension and incline. The robot must securely grip ropes with varying tightness and angles. Additionally, we aim to optimize the design, develop and integrate an Arduino system and a sensor system, conduct mathematical and technical analysis to ensure functionality and performance. Here you can see ARChie in action. The robot maintains its stability while moving seamlessly along a flat rope. Thanks to its distance sensor, it detects obstacles and stops its movement when the distance reaches 5 centimeters. The two front arms handle the forward motion, while the two back arms help with the grip and overall stability. Here you can see the sensor system, and it stops accordingly. Since our goal was to create an adaptive robot, ARChie can also maintain its stability and move efficiently on ropes with varying inclines. It adapts to these inclines while maintaining a balance and grip, as you can see here. We've had many designs throughout the designing process, but each time we've optimized certain parts and finalized with this design. This design consists of 4 short and long arms, 4 hands, and the main body that can carry the Arduino, motor driver, battery, power bank, and motors. There are two important mechanisms in this design, which are the grip mechanism and the movement mechanism. The hands functionality was to grab the rope. They are designed according to be able to create a well grip strength to stabilize the robot through the rope. The arms functionality was to conduct the movement along the rope. With the torque they receive from the motor, they turn accordingly and create the movement. Here you can see the movement from the design.
The process starts with an Arduino board. When the system is turned on, the Arduino receives a start signal and begins processing inputs from an ultrasonic sensor. This sensor continues to measure the distance between the board and its target. Once the board is within 5 cm of the target, a stop command is sent to halt the movement. The motion itself is powered by the motors that generate torque. The short arm rotates the long arm, and which then control the gripping mechanism. The gripping mechanism securely grabs the rope, enabling smooth and precise movement. On the hardware part, there are hands, LiPo battery that fed our systems, long arms, crocodile cables in order to make a proper connections, Arduino board, power bank, motor driver, short arm, motors, and an ultrasonic sensor. In mathematical modeling, most crucial part of our test setup is the investigation of the slip possibility of our monkey boat on an inclined rope. To do so, we have aimed to demonstrate whether our system can hold on an inclined rope through motion. As you can see on our graph, we have a varying angles of our x-axis and force in terms of Newton on y-axis. Yellow line demonstrates the grip strength of one arm that is produced. Blue dashed line is the friction force that is required to prevent slip motion, and the red line demonstrates the capability of our system which it can produce as maximum. Since on our system, two of our arms will be in contact with the rope all the time, we have obtained a passive friction force almost equal to the lateral force that our system will be faced with. And also, with additional contact of our movable arms, a periodically increase and increase our top possible friction force. And as it can be seen through our plot, we have obtained a safe amount of friction resistance, and it demonstrates the safety of our system.
To reach the maximum safety and tolerance conditions, we have performed analysis and improved our design. Since the movement occurs on the arms, the maximum stress occurs on the short arm part when the arms turn, as you see. Here you see the whole part experiencing a load as a force applied at the bottom part of the body. With the analysis, we proved that our design can carry a load of 3 kilograms. And lastly, you see one turn of the motor and the motion of the arm in the animation format. And here you can see how the stress state changes according to the position. This was important for us to understand the possible failure and fracture points so that we could adjust the design to support those points with either extra material or changing the part design with fillets and curves instead of sharp corners. With our analysis, calculations, and then the real-life experiments with our robot, we could reach these results. Our robot is capable of stable climbing on ropes thanks to its four-arm design. light material, motor power, and software design. We tried to reach maximum energy efficiency. We first tried designs with pulleys and gears, but they were not energy efficient. So with iteration, we decided on the direct transmission of motor power to arms. So we reached a safe, adaptable, controllable, and efficient robot named ARChie. To conclude with, ARChie can walk on different ropes safely while keeping its balance, and it can stop its movement. And in the future, this design may be improved for transportation of goods to the places that are hard to reach. Here are our acknowledgements. We thank to Selim abi and Mehmet abi, and also our Professor Çağatay Baştan and our TAs. And here are our references. Thank you.